Hi everyone, today we will take up a question on capacitance. Two metal plates form a parallel plate capacitor. The distance between the plates is d. A metal sheet of thickness d by 2 and of the same area is introduced between the plates. What is the ratio of the capacitance in the two cases? So we have a parallel plate capacitor. These are the two plates of the capacitor. Let us say this side carries a charge of plus q and this side carries a charge of minus q. The distance between the plates is d. Let us say the area of the plates is A. Therefore, capacitance of this parallel plate capacitor C would be equal to epsilon naught A upon D. Now we introduces a metallic sheet of thickness d by 2 in between the plates. After introduction of this metallic sheet, this parallel plate capacitor will behave like two capacitors each of thickness d by 4. How exactly this happens? Let's try to understand. Let's say there is an electric field due to the plates of the parallel plate capacitor E. After introduction of this metallic sheet, which is a conductor also, there would be induced charges on each side of the plate. This plate will have negative charge and this plate will have positive charge. These charges are induced in such a way that the induced electric field is equal and opposite to the external electric field. So this induced electric field is opposite to the electric field we had because of this parallel plate capacitor. So electric field inside the conducting slab or metallic sheet becomes 0. And the charges on both the sides of this slab, rather the magnitude of the charges are equal to the charges on the plates of the parallel plate capacitor. So now this parallel plate capacitor behaves like two parallel plate capacitors, each of thickness d by 4. Since the thickness of the new parallel plate capacitor is d by 4, its capacitance would be equal to epsilon naught A upon d by 4 equal to 4 epsilon naught A upon d. Similarly, the new capacitor on the other side will also have the same capacitance, 4 epsilon naught A upon d. Since these two capacitors are in series, let's calculate their capacitance. This is equal to 2d upon 4 epsilon naught A. This is equal to d upon 2 epsilon naught A. Therefore, C dash is equal to 2 epsilon naught A upon D. Let us find out the ratio of C upon C dash. The original capacitor had a capacitance of epsilon naught A upon D, and the new capacitance of two capacitors is 2 epsilon naught A upon D. So the ratio is 1 upon 2. Alright, thank you very much.